Okay, we want to talk a little bit more about acceleration. Okay, so we have our definition for instantaneous acceleration, and we want to talk about what we mean by change in velocity. So remember that velocity is a vector quantity, and so we have to consider the ways that a vector quantity can change. So we have A, instantaneous, is the derivative of v with respect to t, but this v has a little arrow on top, and that tells me it's a vector. And so that means that it's got both a magnitude and a direction. And so we can change either of those two things, and that's going to represent an acceleration. But let's see how that works in practice. So if we have both a magnitude and a direction, and we change either of those things, we're changing the vector. We're creating an acceleration in the case of a changing velocity vector. We can change the magnitude of the velocity. What does that mean? It means it either speeds up or it slows down. Whatever is moving is either going to speed up or slow down. We're changing the magnitude. Remember, the magnitude of the instantaneous velocity vector is just the speed. And so if we change the speed by either speeding up or slowing down, we're changing the velocity. The other thing that we can do is change the direction of the velocity vector, and that represents a turning. We were going in one direction, we changed to another direction, we turn. And so either of those things is going to represent a change in the velocity vector, therefore an acceleration. So I just wanted to briefly go over the different possibilities here. So the first case scenario that we have is the acceleration in the velocity or in the same direction. And so I've got some box, it's moving with some velocity, and it's also accelerating. And if the velocity and the acceleration are both in the same direction, the speed is going to increase. And so we could say that this is in the positive x hat direction there, and both of them are in the positive direction. Now, here we have a scenario where the velocity is in the positive direction, but the acceleration is in the negative direction. And so what we're going to find out in this case is that the thing is going to slow down. And so this is something that leads to a bit of confusion, because we have a situation where the acceleration is in the negative direction, but the object is slowing down. And so a lot of people infer from that that a negative acceleration means that the object is slowing down. But that is not why the object slows down. It's not because the acceleration is in the negative direction. All that a negative acceleration means is just that. It means that it's pointing in the negative direction. So I've defined my positive x to the right. My a is pointing to the left. That means it's pointing to the negative. That's all that a negative acceleration means. It does not mean that it's slowing down. It can be true that a negative acceleration is happening when something is slowing down, but it's not because it's negative. To see how that plays out, what's going to happen in this situation? So what do we have here? We've got the velocity and the acceleration are both in the negative direction. Well, this guy is going to speed up in the negative direction. It's not going to slow down even though its acceleration is negative. So that's what we mean when we say that a negative acceleration does not necessarily mean that the object is slowing down. Here we have an object that's speeding up, but it's accelerating, it's speeding up in the negative direction. So here's the real takeaway. When the velocity and acceleration are parallel, the object speeds up. In other words, if they're in the same direction, they speed up. Now, when the acceleration is in the opposite direction from the velocity, and there's a word anti-parallel for that, we can say that the acceleration is pointing one way and the velocity is pointing the other way. That's going to be a situation where it slows down. But if the velocity and the acceleration are in the same direction, and it doesn't matter whether it's to the left or to the right, it's going to speed up. So speed up, slow down. These are the two options if the acceleration and the velocity are along the same line. So here's a conceptual example of how this can come into play. Let's say I throw a baseball into a very strong wind, and so the baseball's got some velocity. It's moving to the right, but the wind is moving to the left, and the wind is creating an acceleration to the left. And so what's going to happen? I throw this ball into the wind's going to slow it down. And eventually, if the wind keeps going and the ball hasn't hit the ground yet, the wind is going to slow it down until the velocity stops. You'll have zero velocity just for an instant, but that wind's still blowing, so what's going to happen to the ball? It's going to blow back in the opposite direction, and it'll speed up to the left. And so here we have the velocity is opposite the acceleration, so it's slowing down. And here we have the acceleration is negative, but it's speeding up, and so the velocity is increasing. And so that's kind of what I want you guys to take away from this, understanding what's happening with the velocity vector for different types of accelerations. Now here we have a different scenario. The acceleration is perpendicular to the velocity. So here's v is going in the x direction, a is going in the y direction. And so that means that this acceleration is not going to change this velocity at all, because this is only going to change the y component of the velocity, not the x component. So the x component of the velocity, the left to the right motion, is not going to change at all. But what it's going to suddenly do is it's going to create a motion in the vertical direction along the y-axis. And so instead of continuing to go off to just to the right, it's going to continue going to the right, but at the same time it's going to be going up, and it'll go off at some diagonal angle. And so the A is going to create a turning effect. So if without this A here, this guy's just going to keep going in a straight line forever. But once I apply this acceleration, it's going to go off up diagonally. And so this is the key thing, that if I have an acceleration that is perpendicular to my velocity, the object is going to turn. Now, of course, we can look at a general case, and here I've got an object with a velocity that's pointing in the negative direction and an acceleration that's at some angle. And I could, call that angle theta if I wanted, whatever angle I want to name it. But this acceleration has two different components, one that is parallel to the velocity and one that is perpendicular to the velocity. And so this guy a sub x, that's going to change the speed. Now, in this case, this a sub x is opposite direction of v, so that's going to slow it down. If the a sub x were in the same direction as v, it would speed it up. It's that simple. This a sub y, on the other hand, is perpendicular to my velocity, and so that's going to make it turn. So the general case is an acceleration that has a component that makes it speed up or slow down, the one that's parallel, and one that's perpendicular that's going to make it turn. So you can simultaneously either speed up and slow down and turn. Now the last thing I want to ask is, what is it that determines whether an acceleration is positive or negative? And that depends entirely on your coordinate system. So here I've got an object that's accelerating. Both objects are identical. I've got the object up above is accelerating to the right, the object below is accelerating to the right. But what's different is I've created a different coordinate system. I'm allowed to put my coordinate system anywhere I want, to turn it upside down, to invert it, to turn it at an angle, to do whatever I want to it. I can set it anywhere that I want as long as I'm consistent. And so if I do this, this is the same acceleration now, both cases to the right, but up above that would be a positive acceleration, and down below, because I'm defining my positive x to the left, this acceleration to the right would now be a negative acceleration. So the positive or negative of a vector is defined entirely by where you put your coordinate system. That's true for any vector, including acceleration. That's why I don't want you to get caught up into this trap that thinking that acceleration being negative means something is going to slow down. It just means that's how you oriented your coordinate system so that it's pointing in a direction that we have named negative. Speeding up or slowing down, that's going to be whether it's parallel or anti-parallel to the velocity. In other words, in the same direction or the opposite direction. That's what's going to tell you if it speeds up or slows down. And of course, if there's a component perpendicular, it will also turn.